Hello and welcome to today's online event. Before we get started, there are a couple of housekeeping items that we would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located below the slides window. You can also use the question and answer box to get technical assistance. Today's presentation is being presented via web only, so there is no teleconference dial-in. You'll need to make sure that your computer speakers are turned up in order to hear the presenter. You can also fine-tune the audio by using the volume controls inside the media window. The presentation console allows you to interact and customize the layout to fit your viewing experience. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner of each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of the presentation console. I would now like to hand things over to the presenter.
Hello everybody, my name is John Tompkins and I am a cloud architect with VMware's internal private cloud team. I'm here today to sort of give a webinar on the evolution of how VMware's internal private cloud platform has evolved with NSX with sort of a specific focus on some of the challenges that we faced around automation and how we've gone about addressing those over time, both as we've changed our design and some of our operational models. Just to give you a little bit of background about myself, I have a traditional Cisco network engineering background. I've worked for a few large enterprises, both in operations, implementation, engineering, and also some hosted voice over IP cloud provider platforms. And I came to VMware about 2 years ago to get a little bit deeper into the software-defined aspects of networking and to sort of start that evolution from traditional CLI-based network engineering to sort of a more network programmability aspect of managing a network. So our roadmap for today, just a quick overview here, is I'm gonna do an overview of what our private cloud platform is all about, how we got started, how that platform kind of grew using vCloud networking and security, some of the problems and challenges that we faced as we started to grow with NSX, and then where we are today with NSX everywhere and sort of what some of our future plans are. So to kick things off with the private cloud overview, VMware's private cloud is really focused on scale. Today we have a footprint of 6 data centers across the globe. We have more than 20 individual cloud instances. Cloud instance for us translates into a deployment of a cloud management platform. Those cloud management platforms manage just over 115 vCenters. Those vCenters are running a little over 2,000 ESX hosts, and on any given day we have somewhere between 55 and 60,000 active and running VMs with 100,000 VMs that are available. An available VM to us is one that may be deployed, it takes up disk space, but it's not necessarily powered on and running. Internally, we serve kind of a wide range of customers, so our private cloud was really designed to scale, but also to be sort of an agile beast, I guess. One of our main goals is when we started off, was to compete with public cloud type services like Amazon or Azure, and internally, some of the folks that use our private cloud are our technical marketing teams, our education services. So if anybody on the webinar has taken a NSX install, configure, manage, or a vSphere install, configure, and manage course, the labs for those training classes are typically hosted on this platform. Our R&D teams actually use this cloud for like topology reproductions for testing software. And then anybody who's ever opened a support case, our global support services team can actually take copies of customer VMs. They can import them into the capacity in our cloud, and they can use that capacity to do customer problem reproduction, to actually do deep dive troubleshooting into end customer problems that can ultimately feed back into product bugs or any other kind of solution for an issue. Our private cloud platform straddles kind of an interesting line between traditional internal IT and VMware's R&D department. We actually report up through our R&D department at an executive level, and we are integrated into the release cycle for both vSphere and NSX. So before either of those products can be released to manufacturers, we have to have at least one deployment of that product running in our cloud at least 4 weeks before that process happens. And then before the product can actually be released GA for customer consumption, we have to have 25% of our cloud running that product. So how did we get started with this? Where did this platform really evolve from? It's kind of what I'm going to talk about here next. We used to have sort of a traditional, every group within VMware would kind of do their own thing. Developers would create the software, and they would test it on their own little sandbox environment across each business unit. And ultimately, we sort of realized that was not a very efficient way of going about doing things. So we tried to centralize this into one cloud platform with the idea of running our own products, running them first at scale, and then hopefully we would actually be able to catch more issues before the software actually goes out for public consumption. So some of the main goals behind creating this private cloud platform were to create a multi-business unit infrastructure as a service cloud. We wanted to allow for both internal and external connectivity so people could put different types of workloads in there. We wanted people to be able to put in things like training class labs that could be accessed from training centers across the globe, but we also want developers to be able to do testing topologies that are only accessed within VMware, and those aren't publicly available. And by doing this, we actually we can increase the scale of some of these smaller isolated environments the individual business units used to run. And the goal was to sort of increase our agility. Instead of having to go out and buy hardware for each individual business unit, you just have 4 or 5 different hosts. We can ramp up that scale, but also we should be able to make it more consumable and be able to move faster. So what did our first iteration look like from a conceptual model standpoint? We operate under kind of what we call an availability zone. We actually refer to it as a silo. So within a silo or within an availability zone for us, we have 2 different pools of capacity. We have one that we either call SuperCore or our vCore 0, which is our management, sort of a traditional management cluster. That's where our vCenter VMs, our NSX manager VMs run. And then we have a pool of capacity that's actually handed out to tenants where it's really just tenant deployed VMs that are running. We don't have any kind of infrastructure management VMs there. And we call those our vCore Virtual Core 1 Plus. So to orient you here to what we're talking about from a conceptual standpoint, our management stack is built on vCenter and ESX. We had 2 separate clusters to start with. One that was actually for management VMs, things like the NSX managers, the vCenters, DHCP servers, DNS servers, anything else we need to run the entire environment. And then we also had a separate cluster that was based on vCNS. And for those of you who aren't familiar with vCNS, vCNS stands for vCloud Networking and Security. And it was kind of one of the precursors to NSX, where NSX is today. That was deployed as part of the vCloud suite before VMware acquired Nicira. And in our capacity clusters, it's kind of the similar setup to our edge cluster, where you have vSphere with ESX and vCenter running on top of individual clusters, and those clusters are prepared for vCNS. One of the things that was really sort of a limiting factor for us when we first started is that we were running vCloud Director 1.5. So in earlier versions of vCloud Director, some of that tenant networking wasn't able to consume VXLAN and network overlays. So a lot of our tenant networking was VLAN based. So what does this look like from a quick topology standpoint? What I'm kind of going to do for each of these iterations is review how the conceptual model changes as our design has evolved over time, and then kind of review what our logical topology looks like from a security zone standpoint. And then once I kind of review those for each of the iterations of our private cloud, I'm going to go over some of the challenges that we face with that and how we've tried to address those with automation. So from a logical topology standpoint, we organize around a few security zones. So like I mentioned before, we wanted both internal and external access for one cloud tenants. So that internal access calls into a security zone that we call trusted, and that external access falls into more of a traditional DMZ type zone, where we also have an internet connection over here on the right-hand side through a firewall and NAT services that are run by an NSX edge, or in this case a VCNS edge, and down into a tenant who can have both publicly accessible VMs, and those VMs can also access services on the VMware internal network. And then on the left-hand side here, we have those trusted tenants. Those trusted tenants have no access out to the internet directly. they have to go out through a proxy, our standard corporate default route, and those tenants really just look like any other person who would come in and plug into the VMware internal network. So what were some of the early challenges that we faced with this? One of the product limitations of VCNS is that it didn't support dynamic routing. So as a network guy coming from a primarily Cisco background, when you come in and you're working with a network product that doesn't support dynamic routing, you're kind of like, whoa, hey, where'd this come from? You mean I have to go back to doing everything with static routes? So that was kind of a limiting factor of VCNS that we eventually grow out of as we move into NSX. And because all of our tenants were assigned VLAN-based networks, we still have an administrative overhead where we as a network team have to go out for any new tenant provisioning process. We have to go configure a VLAN on our physical switches, and once that's done, we have to follow our change control processes for that. And once that's complete, we hand that back to our build teams who can then take that capacity and deliver it to our tenant. And that's one of the main use cases right now for overlay networks is it reduces a lot of that administrative time so that you can either do self-service or you can deploy it much faster than having to wait for change control processes and building out VLANs on physical networks. And then because this is really kind of us getting started, a lot of that logical network topology was deployed manually. So we would go into our VCNS managers and we would deploy an edge. We click in the GUI. And for somebody who comes from a Cisco background where you're used to doing things through a quick and responsive CLI, going into a GUI to do everything, while it's responsive, it's not necessarily the quickest process in the world. So these were some of our initial automation challenges. And the next portion I'm going to talk here is about how we actually grew with VCNS and how some of these automation challenges really kind of evolved with that vCloud networking and security product. It really, for us, kicked off an era of learning as we grew. And our growth requirements, we really had to have more agility in some of our existing deployments. That was kind of one of our foundational principles, was be able to grow at a large scale, but also be agile. And without some level of automation, that agility becomes dependent on manual processes, which are prone to more mistakes, and they tend not to move as quickly if they can't be something that's really governed or like a standard change control type procedure. So every time we deployed, made a new deployment, whether our growth was driven by some sort of geographic or business requirement diversity, we made an iterative attempt to approve that design every time we did a new deployment. So the first real manifestation of this was with what we're calling private cloud version 1.5. These versions are really just sort of used for tracking purposes here in this presentation. They're not a formal thing that we refer to this as internally, but the next iteration of our private cloud was marked by the introduction of VXLAN in VCNS 5.1. And at this point, all of those tenant networks, we could take and we could move off of VLAN-based networks and into the virtual world. And for us, this is really a huge thing because this started off an era of self-service where we could take the creation and deletion of networks through our cloud management platform, which is VCD in this case, and we could offload those functions directly to the tenant. So if a tenant had a requirement for a new layer 2 network, let's say to host a new lab, they didn't necessarily need that lab to talk to anything internally at VMware. They just needed to talk to the other VMs in that lab. They can actually just go into our cloud management platform. They click on a button that says, I want to deploy a new network, and it would take care of that all behind the scenes on the back end. At this point, they take that change control process that our network engineering team has to go through out of the picture, and they have almost an immediate layer 2 network instead of having to wait a day or two for a person to go and create a VLAN on a physical switch. So from their standpoint, as a tenant, it's a significantly better experience, and from our standpoint as a network team, it actually offloads some of that day-to-day administration from us, where we can actually focus on more things like design and evolution. So from a concept standpoint, it looks very similar to how we first started, but what we've done is in this compute cluster, where our resource capacity that we give the tenant is, it's still built on VCNS, but it's built on VCS using VXLAN-based networks. from a security zone model, we still have the same concept of a DMZ and a trusted tenant with the same sort of access policies for each. But what we have down here is the very southbound portion of this diagram. You can see that the network type has changed from VLAN to VXLAN. And again, this is really just to give us that flexibility of self-service deployment. So one of the challenges that we had with this second iteration of our private cloud design is that we still are using VCNS, and VCNS still doesn't have support for dynamic routing. And you may ask sort of like, okay, how does that fall under automation? Well, people don't really think of dynamic routing as strictly an automation tool, mostly because it's been around for so long and it's so ubiquitous in the networking industry. But when you go back to not having it, you just sort of realize that there's a lot of manual overhead involved with managing static routes and failover. And what we found is as we grew, our tenant growth caused us to increase the number of VCNS edges. And a VCNS edge, for those that are familiar with NSX, is a very similar concept. It's a VM that has its own resource footprint, and it runs more stateful services, things like load balancing, firewall, and NAT. You can also use it as a SSL or an IPsec VPN endpoint. So we would deploy one of these for each one of our tenants. And because each one of these has its own firewall rule set, every time we deployed a new tenant, we essentially deployed a new VM with its own set of firewall rules. And as we grew on a per-tenant basis, what we found is that you move from sort of a model of one monolithic firewall with a centralized rule set to a large number of firewalls with a very small rule set. And that became a little bit more difficult for us to manage because we distributed that a little bit more than we did centralize it. And then from a manual deployment perspective, we're still doing all of this by hand. So we're doing our deployments of that logical network topology by going in and clicking Add New Edge. For each tenant that we onboard, we go in and we say we want to add new edge. And so we really add this new automation challenge of the tenant growth, increasing our number of edges. But the one thing that we have solved from an automation standpoint is some of the administrative overhead associated with building out VLAN networks. By turning that into self-service through a cloud management platform, it's automated in the respect that it's offloaded from an infrastructure management team. And one of our next requirements was more geographic expansion. Up until this point, our entire private cloud platform presence had been in the US. And we had a demand for customers based in Europe to have a more local presence for them in order to reduce some latency and things like that between connecting from Europe back to the data center in the US. And one of the things that we started to do as we got into expanding to EMEA is based off the lessons learned towards the end of our US deployments, we found that we had outages that were being caused by very predictable things, either misconfigurations. VCNS behaved very much like NSX from the standpoint of you had to prepare hosts, and it pushed out a series of VIBs in order to be able to use VXLAN. So some of those things, if they weren't done correctly, we would actually end up with outages based on some of those configuration items, whether it was something that either wasn't done correctly on deployment or something that broke afterwards. Based off of those learnings, we started to implement BAT testing through Jenkins to go out and look for some of these configuration things so that we could catch problems before they happened. From a network standpoint, I think most people look at network automation from the standpoint of configuration management because that's one of the main problems that people are trying to solve from a network standpoint. How do we go to more of a model where we source control our configurations instead of a reactive model where we go out and we have a configuration on a device, but we back that up on a periodic basis? And one of the things that I don't think a lot of people in the network industry are focused on too much yet is actually automation of how do I know that my network is working the way I expect it to. So this is where sort of a continuous integration and continuous development model comes in. So we started using Jenkins to run some of these tests and be a little bit more proactive about how we look at things that we already knew. The problem with trying to be proactive about finding those configuration errors is that we we're actually very reactive in the sense that we only set up these bat tests after we knew that this was something that existed. And then the other thing that came with, in between our deployments in the U.S. and our deployments in EMEA, really towards the end of our U.S. deployments, is we began to automate our infrastructure builds for new deployments. So as we would go through and deploy a new vCore, a new capacity cluster that we would hand off to tenants, we sort of developed an automation tool internally that we call our One Cloud API. Internally we kind of give it a code name of Umbrella, but what it does is it actually interacts with the APIs of each of the VMware products, vSphere, NSX, VCD, and it can also interact with other automation tools. So as an example, it can interact with configuration management tools like Puppet or Ansible and actually kick off tasks from those. So not all these tasks run in this tool that we use internally. It's more something that we use to orchestrate other automation aspects. So the conceptual idea in EMEA really ended up being very much the same as it was in the US. We didn't make too many changes. We made some changes in the logical network design standpoint to simplify our security a little bit and our edge protection. But from the standpoint of the actual stack itself, it's still vSphere. It's still based on vCNS using VXLAN, and it's still being run by vCloud Director 5.1. And from a logical standpoint, we did simplify some of our internet edge, but what you'll notice here is we have actually added a third security zone. So we have the concept also now of an untrusted tenant. So before we had trusted, who had normal internal access to the VMware network only. We had DMZ, who had internet access, but they also had access to back-end resources on the internal VMware network. And now we have the idea of an untrusted tenant, who's really more of an analog to a public cloud type setup where they only have access into their VMs from the internet. They don't have any internal connectivity at all. So this use case really applies more for something like where you go to VMworld and you go to hands-on labs. If you're taking a lab there from the conference center, we actually have non-VMware employees, just VMware customers who are connecting back into some infrastructure in our cloud and taking labs. So this untrusted model actually gives them the ability to come into capacity without having any access to our internal network. But one of the things that this does to add to our automation challenges is when we were getting towards the end of our US deployments, we noticed that we started to have this sort of edge sprawl that I mentioned before, where we had these vCNS edges that have firewall rule sets on them, and we have a greater number of those with smaller rule sets. So by introducing a third tenant type, we actually have the problem where we're sort of compounding that. We take this third tenant type, and we add more edges that require firewall rules that are associated with that. We'll come back to our automation challenges and see how we've evolved from our US deployments. We still have no support for dynamic routing in vCNS. Our tenant growth has caused the increase in the number of vCNS edges, which, as I just mentioned, was compounded by the addition of a third type of security zone. And we've solved half of our problem from a deployment standpoint. So my manual deployment has now changed to manual tenant provisioning. So we have this concept now where we've used our tool Umbrella to automate the deployment of our infrastructure, but what does that actually do? So at this point, what it does is it deploys vCenter, it deploys our vCNS managers, it makes the connection from vCNS to our vSphere, to our vCenter server, to our SSO server, and it also goes through that initial process of doing the host preparation for VXLAN VIBs. But one thing that doesn't quite do for us yet is from that logical topology standpoint, if we have to onboard a new tenant, we don't have any automation around that new tenant provisioning process. And I put bat testing for network on here. We have, one of the things that I set up front for this next iteration was that we started to do bat testing. But one thing that we're not quite good at here is that we're still doing it reactively. And from a network standpoint, we have a few tests that we started off with on the network side. But for the most part, a lot of those bat tests were focused more around the compute stack. So we have a lot of maturity to gain there from our bat testing on the network side. And just to give you an example of some of the things that we're testing for there is to make sure that those VIBs do exist on a host when you do host preparation, and that it's got a valid VXLAN VTEP interface. Some of our NSX edges, we run them in high availability mode, so we have a test that also runs to look for edges that are running in a split brain mode where both edges in an HA pair may have become active. So at the beginning of, this is probably around first or second quarter of 2014, we really started to get in with NSX after VMware had acquired Nicira and started to take that vCloud networking security product line and merge it with some of the shiny new features that Nicira brings to the table in terms of controller-based programmability and unicast control planes. So our next version were our first few attempts at running NSX. And what we did is we collapsed our management cluster concept into one consolidated management edge cluster. We found that we were using a bit too many resources on edges. So we kind of simplified our design for our management cluster, reduced a little bit of edges there, and we shifted from a per tenant NSX. So with the VCNS environments, we were doing one set of firewall rules per tenant. And what we've actually done is we've rolled those up into a single per vCore firewall using an NSX edge. So this kind of addresses one of our problems where we have this edge sprawl. We were deploying a set of firewall rules on a per tenant basis. And what we did here is we actually kind of addressed that by way of design as opposed to automation. So our conceptual view here is that we now have a management cluster. Our management cluster is still running VCNS as its underlying network technology, but in our capacity clusters for our tenants, all of their underlying networking is being done with NSX, primarily using the VXLAN overlay features. It's based on vSphere. vCloud Director 5.5 is now running it so that it can consume some of those NSX features on the edges. And you can see that we've gone to just a single cluster here in our management, our vCore 0, our management stack. We made a few changes to our logical model. For the most part, it's very similar to what we did in EMEA, but we provided a little bit more separation between our trusted tenants, our DMZ tenants, and our untrusted tenants. From an automation perspective, this complicates things a little bit more because you actually have three separate sets of VLANs and VXLANs that you have to deploy, one for trusted, one for DMZ, and one for untrusted. Prior to this, the DMZ and the trusted tenants were connected to sort of the same topology. But from a security standpoint, this gave us better separation, but it makes our logical topology a bit more complex. So with this new setup, we face some of the same automation challenges that we've been looking at before. One, we have a couple also that we fixed. So NSX brought with it support for dynamic routing. And in this case, we've knocked dynamic routing off as a challenge now. We can run OSPF and we can run BGP with our NSX edges, and we don't have to go through that manual process of configuring and managing static routes everywhere. And we have a little bit of a reduction in that edge footprint because from our design change that I talked about earlier, we've reduced the number of management points that we have for firewall rules. Instead of a set of firewall rules for every tenant on its own separate NSX edge, we've taken all of the tenants that run within one capacity, and we've sort of centralized that into a single set of firewall rules. So this only brings reduction. It doesn't quite fix the problem for us completely. And we still have manual tenant provisioning, so some of the logical network components still have to be deployed manually. We did roll over from VCNS to NSX that automated deployment of infrastructure components. So the NSX manager, the vSphere components, so vCenter, the association with NSX manager to the vCenter server and to the SSO server, the host preparation, and VXLAN network preparation. And one of the new challenges that we have now is we're actually trying to keep pace with design changes. You may have noticed that each time I've gone through one of these iterations, we've made slight tweaks to that logical network design. One of the things that's really prevented us from doing is having a consistent design. And one of the underlying things for automation is if you're going to automate it, it should be consistent. So because now NSX is sort of a new thing for us, we're looking at this point, still early in 2014, we were looking at using things like distributed routing, distributed firewalling. So our design changed a little bit from those VCNS days where it was all edge-based. And we're still primarily edge-based from an NSX standpoint at this point in our history. But like I said before, we kind of shifted from a per-tenant NSX edge to an aggregate NSX edge that controls routing for all of our tenants. So one of the things that we didn't do up front here was when we were doing these logical network deployments, we didn't have any automation written for that from a VCNS standpoint, where it would have been easier for us to just modify that automation for NSX. We really, at this point, got behind the power curve a little bit with our design changes. And as we've gone on, again, we're learning from our past mistakes, and we're adding bat tests for new things. But we're still reactive, and we're still not following like an integrated CI/CD type model with the rest of our configuration changes. So NSX everywhere. Our first experiences with NSX were really sort of that, migrating from VCNS to NSX. And NSX everywhere brought in some challenges for us in terms of going back to our VCNS environments and actually getting them current, doing upgrades and bringing them to the NSX versions that we wanted to be running. So 2.0, we have NSX running everywhere. From a conceptual standpoint, this means that we are now fully running NSX in our capacity cluster still, but we've also run an NSX now in our management cluster. And we have two aspects here that we're looking at. Any new deployments that we've done were built out this way. And then any existing deployments, we had to go back and do an upgrade process. So a huge focus for us throughout 2015 was going back to retrofit all of our VCNS deployments to run NSX. From a logical network security zone model standpoint, nothing really changes. We're still doing a separate trusted DMZ and untrusted topology each, with very few shared components there. So our logical topology doesn't change in terms of complexity, but we still have more of these deployments that we're building out. So each time we add a vCore, we build out this topology one more time. So we still have this growth of edges that it's a challenge for us to manage. So our automation challenges with this round of our design iteration was we still have this number of NSX management points that has kind of been growing over time. We've grown a lot. We have these new deployments, and with each one of those comes a good number of NSX edges that have their own set of firewall rules. So this is still a challenge for us, and it's actually still a challenge for us today. And we have actually at this point eliminated one of our automation challenges in the form of tenant provisioning. So our tenant provisioning, we actually implemented automation through ServiceNow, which is our request management platform. And in ServiceNow, we have a workflow that goes through and you collect all the information around requirements for a particular tenant. So things like CPU requirements, memory requirements, disk space, and then also how many networks and what size those networks need to be. And then ServiceNow packages those up as variables, and it passes those along to our tool umbrella that we use as what we call our private cloud API. And then it takes that information, and it does a lot of the NSX deployment using vCloud Director. So for those of you that are familiar with vCloud Director, you can deploy an edge through vCloud Director. It actually goes out to NSX, and it deploys an edge in compatibility mode. It's actually a VCNS edge. And then the automation goes through and upgrades that edge. And it configures all the networks that it needs to connect to, both for its upstream networking and downstream services towards the tenant. So even though it's an NSX component, it's not deployed and configured directly through NSX. We do it through the cloud management platform, through this automation. And then keeping pace with our design changes, 2015 for us actually saw a shift from growth in our infrastructure as a service vCloud Director-based cloud. We actually had some new services that we wanted to bring in. So we had a vRealize automation deployment that the Cloud Management Platform's business unit wanted to kind of get spun up so that they could start doing actual VRA development and testing there and using it for themselves to do that. And we also had 2 VDI deployments that we worked on in 2015 where it was kind of a new, we couldn't necessarily reuse the logical network design that we had for our infrastructure as a service. And it actually gave us a chance to use some of those newer NSX features, things like distributed routing. So we came up with new logical designs for each one of these new platforms that we rolled out. And we also, at this time, we're also playing with things like VIO, VMware Integrated OpenStack, and Cloud Foundation. Back then it was known as EVO, and it's now VMware Cloud Foundation. So for each of these new deployments, it really represented kind of a new frontier for us. And before we had been evolving our VCD infrastructure as a service design, and now we're suddenly doing these new deployments that have completely different logical networks. And I think one of the lessons that we learned from this is that if you don't go through the process of automating these new deployments up front, it's actually more work for you the second time around. So as we went through this, we did our VDI deployment, and we did the first one in X amount of time. And then our executives came back to us, and they said, awesome, that's great. Now we want you to do a second deployment, but we expect you to have it done 2 weeks faster. So because we didn't do the automation up front with the first deployment, if we go through the second one, we can do it manually, and we can probably still do it 2 weeks faster. But if we had worked on some of that automation up front, it does take time to write that initial automation, but the upfront time investment actually pays dividends long term when you start to do more and more of these deployments, these repeatable things. So one of the lessons that we're learning from a network standpoint is to actually work with our internal automation teams and get some of these logical network designs automated as we deploy them for the first time. And BAT testing continues to be sort of a challenge for us. We're still reactive in that we're setting up tests to look for things that we already know can happen. But as we deploy, we're not setting these up to proactively test our changes as we roll them out, whether that be firewall changes or NAT changes or even new logical infrastructure deployments. So that's still an area of maturity for us on the network side of things. And those challenges really still exist today. I can't sit here and say that we've got a good solution for them. We're like a lot of organizations where we're not 100% automated. We're getting there. We're working on automation in an incremental fashion. But from the lessons that we've learned from our deployments up till this point, we're now looking at the future. So what do we have coming up for our private cloud platform, through the end of 2016 and really through part of 2017? For us, it's closer partnership with the Cloud Foundation team. So one of the things that I've mentioned a couple of times throughout the course of this presentation is this tool that we use called Umbrella that we use to automate the APIs or orchestrate the APIs throughout our private cloud platform. That's great for us, but it doesn't really provide any benefit to anybody else as a VMware customer at this point. So we are aligning with the Cloud Foundation team. Cloud Foundation really does a lot of the automated deployment of the VMware software stack. So it'll do automated deployment of vSphere, ESX, vSAN, and NSX kind of in one contained package. And we take some of these tasks that we've run into from our day-to-day operational experience, and we go to the Cloud Foundation team and say, hey guys, this is a real pain in the butt for us. If you can include some sort of automation around this in your product, then not only does it benefit us internally, but it's also going to benefit VMware customers that are seeing some of the same challenges with their environments. And one of those things, we spent a lot of 2015 trying to pay off a lot of that technical debt and bring our entire cloud stack to currency. It's not just an NSX problem. For us, it was also a VCD, underlying infrastructure, firmware management, and vSphere versions. So in order for us to have that relationship that we have with R&D, where we deploy new software versions 4 weeks before those software versions get released to partners, we have to be close to being able to run that version. And back at the very beginning of 2015, we were not there yet. So we spent a lot of 2015 doing lifecycle management, getting everything upgraded to vSphere 6. We got our NSX versions upgraded from 6.0 to 6.2. But part of our feedback is that in a scale environment, that's not always necessarily an easy process. So one of the things that Cloud Foundation is looking at doing is integrating lifecycle management for VMware products into the Cloud Foundation product itself. And then we're evolving now that we are moving into an era of hyperconvergence. So trying to run a lot of this scale platform on virtual SAN. So to revisit the 3 automation challenges that we kind of ended with when we moved to NSX that we're still looking at today, how is it that we're trying to address some of these things with our next generation design that we're working on currently? So NSX edge management points. The reason that we're in this situation is that we evolved from a vCloud networking security topology that was very heavily edge-based. And we kept a lot of those same design philosophies when we migrated to NSX. But NSX really isn't known for its use of edges so much as it is for some of those features like distributed firewalling and distributed routing. So part of our goal is to make better use of those for our firewall enforcement, and distributed firewalling gives us more of a centralized point of management for those rule sets. And one of the other things is that from a scale standpoint, if we have a tenant that's deployed across 8 vCenters, we have to manage those rules across 8 vCenters. So some of the things that we're looking at right now with versions like NSX 6.3 are using NSX in universal mode so that we can actually take 8 vCenters and we can run essentially all the VXLAN, the distributed routing, and distributed firewalling with one management point for all 8 vCenters. For those that aren't familiar with Universal NSX, you set up a transport zone that extends across multiple vCenters, and you manage those objects on a master NSX manager that then synchronizes to the other managers associated with the other vCenters, so that you don't have to go through necessarily and make changes to every single vCenter and ensure their consistency. A lot of that's done through that universal synchronization process. That's our main technology solution that we're looking at from more of a technical standpoint. The other 2 problems here are keeping pace with design changes. And I mentioned this before, but there's a lot more benefit in automating new deployments up front. It's easier to start with that automation and sort of tweak it in parallel as you tweak the design before you get too far down the road of making all these design changes with absolutely no automation, and then you have to come back later and play catch-up. This is a lesson that we've learned on the networking side from our previous experiences because we're still doing a lot of things like deploying NSX edges manually. We're still manually configuring firewall rules or NAT rules. And that's one of those things that it takes a decent amount of time on our side when we should be able to be focusing on architecture and engineering instead of sort of these day-to-day administration tasks. And there are, NSX has really gained a lot of maturity around the tools that are out there to do that. So we're, from a physical network standpoint, we're looking at tools like Ansible and Puppet. And from an NSX standpoint, we're trying to get to a point on the network side where us as network engineers and admins can do things like source control our configurations, use configuration management like Ansible to manage NSX. Or there are even a couple of open source tools out there right now, the NSX Power NSX, the NSX extensions for Power CLI, and there's also a NSX Python library that comes with its own command line called PyNSXV. There were a couple of good sessions about it at VMworld. So looking at those to really use those automation tools to do some of these day-to-day tasks in NSX. And then also for us to get more ingrained in a continuous integration and continuous development model for network deployments. I would say that traditionally there's been a bit of a disconnect between network teams and developers, and that's one of those things that's getting more abstracted as we kind of get close to this software-defined networking space. Everybody talks about DevOps and network DevOps, and how do you actually get to that point? I became a network guy because I didn't like to write code, and if you sit down and you talk to a developer, they probably couldn't tell you the difference between ICMP and IGMP. So writing these CI and CD models and tests for automated changes is a bit of a challenge. So you have these network technologies that developers don't necessarily understand, that network engineers or architects understand very well, but they're not necessarily as versed in the technologies and the principles around how to write things like unit testing and functional testing for those protocols. So from our standpoint, what we're trying to do internally is do a little bit more focused cross-training. So testing is actually a pretty good place to start with network automation, even if you're still working on the configuration management aspect, because you can go out and you can automate testing for your network today, whether you're managing your configuration through automation tools or not. when you go out and you do a change, it's good to have some sort of standard change testing procedure. And instead of, like a firewall change, if you're going to go out and make a firewall change, you can do an nmap scan of ports that are open through that firewall prior to changing the rule set. And then you can do another scan afterwards. But there's no reason that you have to do that manually. Things like that can be written in automation. And what this does, if you do some of this targeted cross-training, you can really empower your network teams to get into these ideas behind the CI/CD principles. Since they understand the config, get them started writing on some of those basic tests, which is where we're trying to go today. And then for more advanced things, you can have some of these, you can still have a request process to a team of developers that focuses more on things like unit or functional testing. But for the most part, I would say for us, we found that the request process of just the network team going to a team that specializes in automation and requesting various automation tasks isn't incredibly efficient. They typically work through some sort of Agile or Scrum development module. There's a backlog. You put in your request. Somebody has to prioritize it. They get planned for the next development sprint. So it can be a couple of weeks before any of those things actually come to fruition. And if you can get your network folks to a point where they're thinking about this anytime they make a change, how can they actually test that change in an automated fashion? These are some of the things that we're looking at down the road. So I'd like to thank everybody for coming today. Some of the additional resources I'd like to point you to in terms of NSX, there's a network virtualization for dummies ebook and a microsegmentation for dummies ebook out there. Please feel free to follow these links, and you can download your own copy of these books. And then I'd also like to point you to a registration link. If anybody's interested in attending vForum online for fall of 2016, the date is November 3rd. And if you're interested in catching any more interesting technical sessions, please feel free to reach out to this registration link and sign up for that vForum. And we have been handling Q&A throughout the course of the webinar, but at this point, I will stick around on the line for a few more minutes. If anybody else has any further questions, please feel free to ask them through the platform, and I will be more than happy to answer. Thank you.